Trying that again. Oh my goodness. No audio at all. Hey, let's start that anew. I'm John Park. This is JP's workshop, and now my audio is working. Thank you for the heads up over in the chat. This is one of the great benefits of the chat. Bear says, ironic for a stream about MIDI. I don't know. In my experience, there's no irony in things going wrong when dealing with MIDI and audio. But who am I talking to? These people right here. This is our chat over in Discord. So if you're somewhere and you don't see a chat, you can go check that out. It's at adafruit.it/Discord. Look for the live broadcast chat channel. That's where people are hanging out. And we've also got our YouTube chat fired up. So hello, Samir Musa, Dave Odessa, Johnny Bergdahl, Tyeth Gundry. Hello. Thanks for joining us. Tyeth says, I've entered just as a snowstorm ended. My goodness. We're probably in the 70s or 80s now here. Fahrenheit. It is getting warmer in Southern California. All right, and hello in our Discord chat. Who we have here? We've got Bear, we've got DJ Devin 3, Johnny Bergdahl, Paul Cutler, Starman, Snaky Maker Cat. That's a lot of things. Sam J, Ohio. C. Grover. See, there's a brown noise attack. Uh-oh. What does that mean? What does that mean, C. Grover? I hope everything's okay. I do have the AC running to cool it off in here, so maybe you're hearing a bit of that. I don't know, but let me know. Let me know if the levels are goofy or something else is going wild. So I've got a show here for you today in the workshop. We have got a coupon code for you so you can save some money in the store. We've got a recap of the product pick of the week this week. I have a pretty snazzy I think. Pretty snazzy CircuitPython Parsec. C. Grover says, brown noise is okay now. You know what, that was probably when I turned on the mic receiver, but the transmitter was not yet on, and that makes a heck of a racket, so sorry about that. I thought this pack was on. What else do we have? I have solved the mystery. If you've been here for the last couple weeks, there was a mysterious mystery about the Pico RP2040 with the GP2040CE gamepad firmware on there, not wanting to go into the configuration mode, the web configuration mode. I solved it. It was an operating system level thing of all the things. So I'll show you what that was, and then we can finally take a look a little bit at the configuration for this groovy firmware. I have a little guide wrap up I'll do. I'll show you the learn guide I made for that project for the Pico arcade stick. And then I've also got beginnings of a new project. That's this MIDI masseuse right here, MIDI massager, MIDI masseur, MIDI messenger, something like that. I don't know exactly what I'm going to call it yet, but it is a USB host MIDI feather that we can plug MIDI keyboards into and then do stuff with that MIDI data before we transmit it along to the synthesizer. So yeah, that'll be cool. What else? I think that's it. Yeah, so let's start off with the coupon code. Hey, thematic. It is MIDI host. That's right. The coupon code today is MIDI host, and that means if you head on over to adafruit.com, which is this right here, you can pick any of these delightful things and put them in your cart and save 10%. So, you know, for example, because of the easy math, I'm attracted to that. Get yourself some flat tip ESD plastic tweezers, not for $2.50, but for $2.25. Everything you throw in your cart, you can take 10% off just by typing in that coupon code MIDI host. That is good on physical goods, not on software, gift certificates, subscriptions, but on physical things that you can get, you will get a discount. So head on over to Adafruit, look around. If you head to products, you can go to the different categories, you can see the featured products, you can see all of the new products. We've got some neat stuff that just came out, this low power wake up timer breakout. We've got a new cutie pie, the aforementioned tweezers, and on and on. You can get yourself a nice discount by throwing some of those things in the cart and then typing in MIDI host in that coupon code slot on your way out. We've also got some freebies. So if you just want to type in adafruit.com/free, you'll see some of the goodies you get at different price points. So if you spend $99 or more, you get the free PCB coaster. $149 or more, you get the coaster and a KB2040 microcontroller breakout. If you order $199 or more, you'll get those two as well as free UPS continental US ground shipping. And if you spend $299 or more, you'll get a Circuit Playground Express for free and the UPS shipping and the KB2040 and the coaster. So those are all the current freebies. Go check those out if you want, adafruit.com/free. And you'll just see those appear in your cart. You don't have to do anything to get those. If you just spend as much as one of those breakpoints, you will see a little automatically added item in your cart, such as, hey, coaster, free coaster. All right, hey, Randallbone. Randallbone says, beep, boop, over in the YouTube chat, and I agree heartily. So next up, I've got this show on Tuesdays that looks like that. It looks like splat, me hitting my face against the glass. It is a product pick of the week show. I pick a cool product and I give you a big discount. This week it was a 50% off on this one. Do some demos, show you how it works, show you some code, and here was a little 1-minute recap of this week's product pick. The TCRT 1000 photo reflective sensor. This is a stemma sensor, meaning we've got the little 3-pin stemma connector there, so you can plug that into your project. If something gets between about 0.4 to 1 millimeter away, which is adjustable with a little trim potentiometer there, it will trip the switch. I've got the 3-pin JST cable running to, in this case, a Pi portal. When I get close enough to the sensor, you'll see it trips. As I spin my disc here, I'm able to detect the markings there, which is something you can use for robotics, to have precise wheel positioning, a pair of these to be able to tell direction as well. It operates quickly. It's faster, I think, than my screen there can update. TCRT 1000 photo reflective sensor. And I think I might be doing a project with those. I dug out this old one here that I showed during the demo there. This was the CircuitPython disk sequencer, little drum sequencer, and I may revisit that using our new little breakout. Might be a nice way to do that. Let us see, what else have we got? Oh, all right, let me get set up for this, because this is a nifty one. Okay. For the, what was that noise I'm hearing? Oh, it was outside. I thought I suddenly had feedback. I'm losing my marbles. For the CircuitPython Parsec today, I wanted to show you how you can change the USB identification name inside of CircuitPython for your microcontroller board. So what you see right here, I have a Feather board. This happens to be a Feather RP2040 USB host. And in fact, right now in my little console, you can see if I use something like TO or Disco Tool to see what is plugged in right now. I've got a Trinket sitting over there, and then I have the Feather RP2040 USB host. So that is the name that shows up in programs that have access to that USB device, and they want to tell you what the name is. Sometimes after you've created the project, you want to give it a more specific name than just the generalized microcontroller board. And that is where this boot.py comes in. What you can see here, I'm going to try to zoom this up a good bit so you can see that a little better. I have a boot.py program on the microcontroller, and in it I am importing the supervisor library, and then I'm using this command, supervisor set USB identification. Then you can tell it a manufacturer name, which is a string, a product name, which is also a string, and then you have these vendor and product IDs. In this case, we're using the Adafruit vendor ID and then just sort of a made-up PID. So what I'm going to do is resave that boot.py, and I think I can just rerun. No, I'm going to have to either reset it or power cycle it. I think it's power cycle it. So now what I'm going to do is power cycle the board. This time it's going to run This time it's going to run that boot.py and find out that it has a new manufacturer name, a new product name. So if I go and look in my console here and say Disco Tool, it says, oh, the product there is MIDI Dude. And we can see that inside of other things like Ableton Live, other programs that are accessing USB. It'll tell you a new name. So this is a really cool way that you can sort of personalize your project after you're done with some of the development. And that is how you can set the USB identification names inside of CircuitPython using boot.py. That is your CircuitPython Parsec. I do not know what poot.by would do, but I don't even want to test that one. And in fact, while I've got this one plugged in and up, I just want to show you another instance. Let me fix, I think I might have this. Okay, yeah, so this screen capture is working now. If you look here, this is the VC VRAC modular synth software, and in it, I can pick different USB devices for my MIDI input. If I look at this list right now, it is, let me go to no device. see, I might have to, let me see, how can I refresh that? It's showing a previous name. Oh, MIDI masseuse is showing up. That's like one name ago. And sometimes it takes like a couple of refreshes of things before they catch up with changes. I'm going to unplug this again and try to go to no device on these. And let's see, when I plug it back in, I think it'll find it under its new name. Did I? No, I had that as MIDI dude. I'm not sure why. It might be that I need to close and reopen this software in this case. It might be hanging on to that, that information there. But pretty cool. So we'll pretend that that's what I changed it to. You'll see that show up in your software if you launch the software after you've relaunched the device, power cycled it. And I can't remember if anyone knows what are the different circumstances under which it will sort of refresh that name. I think it's just the power cycle. It might be a hard button reset versus a just a soft reset. I don't think the soft reset does it. So anyway, that was a cool tip from Todd. ToddBot has some cool MIDI products out there on his Tindy store and other places, and it's pretty snazzy when you get something like an Adafruit board, but you plug it in and it gives you a more specific implementation, specific name. David Essa says the workbench is looking unusually clear. Yeah, well, you know what? The last thing on there was the big double joystick thing, which we're going to talk about in a second. And so when I put that away last night and put it back over there, suddenly a lot of space opened up. ToddBot says, historically, USB enumeration is expensive, so there's a lot of caching that happens. And hey, Steve, OKRon says, on macOS, sometimes you need to clear out the device in audio MIDI setup. Yeah, there's a few different things that happen there. All right, so maybe we'll try that later. Actually, I may try quitting and restarting VCRack because I think I saw earlier it was able to find the new name just on launch without going to the audio MIDI setup. But and I think I saw Ableton Live was pretty cool with the new name showing up as well when I power cycled it. Steve also says over here in Discord, microcontrollers will get listed in the network settings. It is funny you say that, Steve, because that turns out to be the solution to the problem I was having with the game controller thing, and I'll show you that. I'll show you that now. So let's jump into this. So I'm going to go over to this Chrome window. Let me find that. And so to refresh memory, the big joystick project that I'm doing, I'm using a Raspberry Pi Pico RP2040 and this GP2040 CE firmware. It's an open source game controller, fight stick, gamepad firmware. It can show up as a Switch. It can show up as a PlayStation controller, an Xbox controller, X input, direct input, some classic controllers. So to change those things, you need to access settings on the board. When you install this firmware, which is just a drag and drop UF2, you'll see here on this page, this is documentation about the web configurator. It says all you got to do is plug the board in while holding down the pin on the S2, which is sort of a generic name for a pin regardless of board. In my case, that's GPIO 17. But the S2 pin is what I'm using. You can use as like player 2 start, or I'm using it as my start button when I'm doing MAME stuff, and the S1 button as my coin button. Either way, it says, hey, when you plug it in, hold that down and you will get to the configurator. And that did not happen last week on the show, and it didn't happen the week before on the show, even though while I was developing this in my inside workshop studio in the house, worked fine. So what was up with this computer? It's like Steve just said, showing up as a network device. So for some reason, this the way this one works is it's going to show up as a USB-based Ethernet device. And on my MacBook Pro, that just magically worked. On this machine, it did not notice that this showed up, and so it had no access to the web server that this was hosting. So I had to go in and add a device in network settings. In fact, let me show this. Let me open up a new little window here to show you where this all happens. That might show. Let me add a screen capture, new screen capture, and let's see if it'll let me just show that window. Hopefully that window is consistent as it changes contents. So system setting window, sure, okay. Okay, so in network, is that going to show up? Yes, okay. So in network here, you can see the two networks that I have are Ethernet up at the top here. I'm connected to it. That's how I'm streaming. And then there's now this tiny USB device. That was not showing up. And so that's why I was unable to access the web settings of this device. So I went down to, and this is specific to the Mac, there's some instructions in the documentation for GP2040 on how to do this in Linux, because I think it also can have some issues finding that Ethernet interface. I went down here to add service. This is probably going to pop up a window you won't see, but from here I picked tiny USB device as the interface. That's what it happened to show up as. Then I was able to get the whole shebang to work. So the way that, where's that window? Where are you, window? Where are you, window? There, Chrome Capture. So the way this works is it says hold down S2, and I've got a, let me switch to a down cam there. So I've got an arcade button plugged into ground and GPIO 17 on here, which is what is going to act as that S2 alias name. And all I'll do is unplug the USB from here, so I don't have a reset button on this one. Oh, actually I do. There's a reset on the, let's try that. There's a reset on the terminal block Pi cowbell here, so I'm going to hold that down, hold S2, let go of that reset button, and now if I follow their instructions and say go to 192.168.7.1, da-da-da-da! I'm so glad it worked, because that was driving me bonkers. So this is now the web configurator at that address, hosted on the little Pico there itself. And this is how you set all of the many, many, many settings. So if we click on settings, you can see input mode. This is acting as a direct input, which is a slightly older fashioned Windows. Microsoft made this, as I think, as a standard part of their whole DirectX, direct input. But this is generic enough to work on most emulators, most computers that you'd be running emulation on. It may also work on iOS, probably works on Android. And this is actually also the same as PS3, Sony PlayStation 3. But if I wanted to take that big double joystick there and use that on a PlayStation 4, I would click the drop down and pick PlayStation 4. And in fact, if I hit save right now, save that setting, and then click reboot up here, it's going to reboot my Pico. And you can in fact tell it, do I want to go into USB boot drive? Do I want to go to web config or controller? I want to go to controller. So now if I take a look at a gamepad tester, it sees this device and it thinks it's a PlayStation 4 controller. And I have just one button on it, which is pressing as this sort of generic-ish mapping to button 9, B9. If I reset, hold down that S2 button, release reset, release the button, I can go back to the web configurator. Change this now to, let's say, a Nintendo Switch. Hit save, reboot it as a controller. Close this tab, go back to gamepad, and now it calls it a Pokin controller, which is a Switch controller, and I think this is probably because some of the game controller USB header stuff was sniffed off of a third-party controller. I'm guessing Nintendo Switch itself was obfuscating things, but this works. When I made my Pokeball macro gizmo, it was using this Pokin controller thing. Again, if I reset, hold this, come back to the web config. Let's go back to direct input. I'll save that, but before I reboot it, we can head over to this configuration tab, check out things like pin mappings. So when you have your buttons plugged into the GPIO pins, you can click on Pin Viewer and find out without sort of tracing wires around, which becomes important when you have a big nest of arcade button wiring. You can just click a button and it'll tell you what that is. Oh wait, I don't think this is in. This might not actually be in the config mode. Let's reload that. Pin viewer. Okay, and when I press it, it says pin 17. So if I ground any of the like 20 or so pins on there, 15 pins, however many we have on this, you'll see them show up as the pressed pin. And you can also do sort of example-based pin mapping. So you can come down here and say, all right, I'm going to map my right to pin 4, change that around with these drop-downs, or go to map buttons with the controller, and it'll just say, what's up? And you press a button. What's down? You don't have to worry about the specifics as much. You can also have multiple profiles on the device. So if you want to switch between different button configurations, you can set up hotkeys on startup that will allow you to pick from these different profiles. If we look at configuration, I won't go through these exhaustively, but interesting things, peripheral mapping. You can choose pinout for things like your I2C if you want to use, let's say, an OLED screen or something fancy like that. You can go into NeoPixel RGB LED configurations. If you have colored light up buttons, you can set their behaviors here. Here's how you do the display configuration. Pick your particular driver chip, like this little SSD 1306. That's we have that in the little 0.91 inch OLED, 128 by 32. I think they want a 128 by 64, so you go to that slightly bigger one, maybe the 1.2 or something like that. You can have little startup bitmaps, and then you can have it display different information. And then the macro configuration is kind of interesting. I was saying I'm going to try to set up the second half of the joystick with another so that my son and I can play fight games, but he's going to whoop me, so maybe I could go to macro configuration here and give myself a little helping hand with some one-button combos. Hit one button and it'll run a macro of a whole bunch of different button presses. So those are the sort of main things to check out in here. And then if I switch over to, let's go to this view and get rid of that. And take a look at this right here. So this is the Learn Guide that just came out for my arcade stick. So you can see it there. I'm running a Raspberry Pi 4 based RetroPie, which runs great. And I have that running that's a Street Fighter 2 Turbo inside of a SNES emulator there. And I do own the cartridge, so this is totally legal. You can see the wiring there. I've got actually a better picture of that I can show you. Got a little video demo. You can see that in action. Let you know the parts. Obviously, one big piece of this is find an old controller, and this X Arcade brand is a good one to check out. There are a few others that are from that sort of earlier MAME era where you'll find big MDF-based cabinets or joysticks. But this would work for anything. It's nice with real arcade buttons and joystick because they're great, and you can plug wiring into them without any soldering. So this is a no solder project thanks to having this little terminal Pi cowbell that you can just screw the wires into. This is out of stock right now, but it should be coming back in stock soon. We do have I believe the one that you have to solder the header pins in, that is currently still in stock. And while it's nice to be able to plug in wiring harnesses into things like these, you can see I've got some of our little breakout spade lug connectors there to just plug into the button. You can solder wires onto things like an old Nintendo joystick or a Sega joystick or something like that. If you've got some soldering skills, you can add this type of thing to any joystick. So under Pico Setup, this will show you how to put that together, how to load the firmware, how to short the pin 17 like I was just showing there to get into the bootloader. I'm going to add a note here about the discovery that I made about why that wasn't showing up on this one. And the settings go over here. This is the kind of default pinout that I'm using. So you can, like I showed you, you can config changes to anything, but I'm using this sort of default arcade button wiring. So you get up, down, left, right on this set of 4. Buttons 1, 2, 3, 4 on these 2 pairs, right and left trigger 1 and right and left trigger 2 on these. We have start and, or rather I have that as select and start. And then third trigger, right 3, left 3. These are usually like the buttons embedded in your analog sticks on a more modern controller. So you could assign those to a lot of different things. A1 is home, so that's things like the PlayStation button on a PlayStation controller. Sometimes that'll take you up to kind of a top level. And I don't think I have anything plugged into A2. I did, however, run to the run, which is essentially reset. So I could hold an external button to reset and go into this bootloader mode or just reset the board. And then I also have this pin up here. I think this is mislabeled. I finally noticed this Raspberry Pi Pico pinout says 3v3_3n. I think, someone tell me if I'm making this up. I think this is the enable pin. Maybe they meant that to be an E. Maybe it's 3v3en enable. Could be wrong, but that works like an enable. So I actually hooked up a switch. So there was a positional switch on the back of the joystick there. So I have that to essentially turn the thing off. Not that you ever really need to do that, but it was there. So you can see I've got a little diagram I made that shows the correlation of all those pins with the buttons on here. And this is this, you could probably use this for picking, like at startup, is it a Switch controller, PlayStation controller, direct input, Xbox controller? You could potentially use this multi-position switch for that. I'm just using it when it's in the 2 position. It's off. Every other position it's on, just based on how that was wired. And then these are my, what I decided to use as button 1, 2, 3, and 4, which then can map to ABXY, that sort of thing. S1, S2 here, those are my select or coin and start. And then this is, you've seen some of the guts of this. This was the original board that was in there, and I happen to have these JST XH 5-pin connectors, and so I used those cables that we sell in the Adafruit store so that I didn't have to undo any of the wiring. I would just plug these into the appropriate pins or screws on the terminal block and then go plug in, and that meant that I saved 100 hours of wiring. There's so much, such a complicated wiring scheme in here with lots of great parallel ground runs or series ground runs. You can see some of it here if we zoom out a little bit. I didn't want to have to deal with tracing all these, so I was able to actually get a lot done just reusing those connectors there. And the terminal block Pi Cowbell has mounting holes on it, so I just used the existing screws and screwed into this little MDF block there it is before I've put it in. And I think one of the last pictures on here I show this screwed into place. So there's 4 screws, or actually I just used 2 screws in the corners there to hold this down. And then run a little panel mount USB cable there so that I can access the USB connection from the outside. And that's where I plug in, detachable, which makes it nice and convenient. We do have the round panel mount version. That's the rectangular one I have there just fit without modification. But where did I lose you to? I do have a sort of round panel mount one that happens to be smaller than an arcade button, so I couldn't fit that into an arcade button slot, and it was smaller than the existing hole, and I didn't want to cut it. But if you got a little Forstner bit or something like that on your drill and carved out a proper size hole for that, you just slide that in. It covers your rough edge there and screws in from the back, and now you have a nice little extension for your, in this case, USB micro B, but you could do some trickery in there and make that a USB-C if you wanted. Some nice says, so surprised the joystick is just 4 limit switches. Yeah, it's very cool the way it works. It's the exact same switches as the buttons have, and this is one that I'm thinking of swapping in for the first joystick right here. Let's take a look at this. This is kind of cool. Let me go to the down shooter here for a moment. Hide that. So, right, this is your typical joystick. This is right now in 4-way mode, but you can see if I go left and right and up and down, it's just clicking those 4 limit switches there. Zoom in or focus that a little better. Yeah. So that's all that's happening inside of there. This one has a little bracket that you can move so that it either allows diagonals. So right now you can see I'm pressing 2 of those at once, which a lot of games is what you want. However, if you're playing something like Pac-Man, you can switch this over. It's not easily accessible, so it's kind of like a do it once and that's what you're going to live with. You don't want to open this thing up all the time, but at least it's not a full joystick swap. But in this mode, it can't press 2 at a time, so it has to let the side one, you're going to hear it click, unclick, click. There's never 2 clicks at once. So that is much better, because if you hit diagonals in Pac-Man, you kind of go the wrong way. So to get around turns fast, this is preferable. So I may swap out one of the joysticks on there, or build a separate little Pac-Man box. Just really needs like 1 button for start. Actually, I need a coin button, a start button, and the joystick. That's kind of all you need for that. So yeah, same limit switches basically as are on the undersides of the arcade buttons that are in that one there. All right, so that about covers it. That's the build. If you want to do one of these, you can look around. I got this one for free. Someone on like a local Buy Nothing group was getting rid of it, and I said, hey, I have a use for that. So I lucked out. If you want to buy these, I think new they were around $250. I see them on eBay for about $85, but the shipping is going to be expensive, so you kind of want to try to find one locally, or go to yard sales, retro game stores, thrift shops, and if you're patient, you may end up with a big old honking joystick like that. All right, that is it for that project. So go check out that Learn Guide if you're interested in this, or just using it as a launching point for your own project. So let's see, next up, by the way, I don't even think I'm going over to the workbench today, because the next thing I'm going to show is right here. So I'll just ceremonially head over there because it's nice and clean right now. Man, this is nice and clean. Actually, it's got a bunch of glitter on it from something else. That's it. That's all I'm going to do at the actual workbench today, because now we're going to talk about this MIDI Monsieur thing. So let's take another look at the down cam here, and I'm going to move some stuff into position. So get this guy out of here. Okay, I can use the workbench to store that. So what we got here is Feather USB host RP2040. And this is the one that I was renaming with the boot.py file before. And you can see I've got over the Stemma QTI2C port a little OLED display there. And this one has both the USB-C that is data and power to the board. So that's going into my computer so that I can program this. And you'll see on the display side it says looking for device. So if I take a USB type A cable that's connected to a MIDI controller and plug that in, you'll see it has just found one, and it's telling me some data. That one actually automatically started sending. I'm going to plug a different one in that's sitting right here on the workbench, and I'll show it to you. And let's see. It may take some convincing. Let me unplug it. So this is using a very newly released USB host library for CircuitPython. Oh good, now it doesn't want to. I have to use that other keyboard after all. I don't know why that's happening. This is so new that I think it has some quirks that we're finding. Okay, so it found that one. Let's see, will you find this one? Yes. Okay. Yeah, so that one's actually going to even play something on my synth here. And if we take a look at the synth, and I'm going to show a MIDI capture as well. Let's see. Let's put that up there, and sorry, I need to add one other. Do I need it? No, you know what? Let's use this one for a second. Here. Yeah, that'll work right there. Okay, so what I'm going to do is Disco Tool. So Disco Tool and MIDI Dude. Okay, so what's going on is I'm playing on this MIDI keyboard here. This has a USB old school type B, big chunky old school type B in there on one end, and it needs to be plugged usually into your computer. It needs to be hosted by something that can do USB MIDI hosting, which typically is a computer, and that's about it. Some high-end desktop synthesizers and samplers may be able to host, but it's a common complaint. We have all these really cool MIDI controllers now. They're inexpensive and all sorts of different designs, lots of buttons, knobs, sliders, pads for drumming, keyboards, and most of them don't have traditional DIN5 MIDI out, so they really aren't that helpful with plugging into a lot of devices because it's complicated to do USB MIDI host. Sometimes the solution is a little Raspberry Pi, single board computer, running Linux, doing some MIDI hosting for you and then sending along MIDI messages. So one thing that people have been really hoping for a long time is that we could do this in CircuitPython using something like this. So this is a Raspberry Pi Pico RP2040 chip on here on this Feather. So it has a USB peripheral here that I'm plugging into my computer on one side, and then it's using PIO state machines to be a USB host on this side that I can plug into. And so what you can see here is when I'm playing notes, I'm seeing the messages here. I'm going to turn down this audio for a second while I... Let's turn that level to nothing. I just don't want to hear that for a second. So as I type, or rather play keys, I'm seeing the note on message, the note off message. If I press a chord, I'll see 3 note ons, a release, 3 note offs. And if I start twiddling knobs on here, so that's cool, right? I'm receiving the messages, I'm printing them here. Let me open up the program that I'm running here. So this is a library that Scott Shawcroft wrote, and some sample code, as well as an adaptation by Todd Kurt that is using Thea Flowers' Winterbloom Small MIDI. We were having problems with stuck notes with the Adafruit MIDI, so we're still looking into that to see what's going on. And what I am doing is, here's a little function called look for MIDI USB device. That's what you saw while it was waiting for something to get plugged in. So it's using USB core find to try to find a device, prints out the manufacturer name, vendor, all that stuff. And then in the main loop, if we have a MIDI device found, it tries to receive MIDI messages. So if it receives one, it says, okay, MIDI device receive. I'm then parsing those as different message types so that I can print them and then pass them along. Now, here's where it gets interesting. Not only can you use something like this as a little, oh, are you not seeing the code? Sorry. There we go. Sorry about that. Thank you for Mike P for letting me know I hadn't refreshed. So here, I'm going to move the move this further out of the way so you can see the code for now. So here's my code, and boop. There you can see the incoming messages getting just sort of spit back out. But the other thing it's doing is it is taking the incoming message and creating a byte stream to send out. And so you can write that out to either a UART, traditional DIN5 MIDI port, like is right here, and or USB out. So this is going back to my computer. That's how you were hearing that synthesizer that's playing on here. So I'm going to turn this level back up. Okay, you should be able to hear that. So like I was saying, not only do you get to see messages show up, like, hey, I'm doing some MIDI CC as I turn knobs, or here's a little pitch bend. If I play, oh, this, I don't have pitch bend hooked up to anything, that's okay. So neat, but what gets really cool is being able to massage that data. So that's why I'm provisionally calling this the MIDI masseuse, because we can do things like, hey, what if I just want to bump up an octave? So here you can see in this uncomment I just did here, if there's a message, if the message type is small MIDI note on, then message data 0, which is the note number, equals message data 0 plus 12. So that's going to bump it up an octave. So here's what it is right now. I don't think I resaved yet. Okay, I'm pressing this one key. I'm going to save. Hopefully it finds the keyboard. Suddenly we're up an octave. Let's go up a whole bunch. Let's go up 24, 2 octaves. Save. Same note, same key. Oh, I got a stuck note. I don't know why. Oh, because I forgot to tell it to release that same note. All right, we're never going to release that one note. What is that? I never played it as 12, did I? All right, let's try that. No, it's never going to release that. Or I'm just going to turn that level down in this software. This software doesn't have a reset. I should add a MIDI panic, which will send out a off on all MIDI notes. It's a good way to solve that problem. So kind of exciting, because then we can start to get creative with, okay, I want to, any note that's incoming, I actually just want to constrain it to a sort of different scale, sort of a quantizing to not chromatic keyboard, but I just want to put a pentatonic scale on there, and all the notes I play are only the good notes. You can do things like build a little arpeggiator. You could build auto harmonizer, so you press one note, it's always going to also play a third and a fifth above. Same sort of thing with CC. So sometimes it is a pain on certain keyboards like this one to change what MIDI CC values come off of those knobs. So what MIDI CC number, I should say. So I can tell this when you see the first knob being dialed here. Right now it says, oh, that's MIDI CC 72. I can change that. I can say, whenever this one comes in, we'll pretend that it's on MIDI CC 24. And now that knob is miraculously, oh, I'm sorry, you're not seeing that. I've got too many windows. Here, let me fix that. There we go. So this knob is actually sending out MIDI CC 1, but my software is changing that to be MIDI CC 24. If I go back to code here for a second, oh my gosh, I'm juggling a lot of windows. Let's go to you right there, and I'll say right here, if the type is CC, which is these continuous controllers, if the CC number is 1, which is what that knob is currently on the hardware, let's send it out as 76, which I think sometimes is a filter frequency adjustment. So now if I move my synth software back over and check that, oh, now it's 76, right? So you could build some pretty neat interfaces for changing what the message coming off of the silly little inexpensive, potentially, keyboard through your little MIDI host here, and then on its way. In fact, this is pre-massage. So that's telling me you're actually twiddling MIDI CC 1. This next knob is MIDI CC 82. You don't really have a way of knowing that with this keyboard. It has its own sort of software control center that you have to download and register and plug in and change it on here. But potentially with a little MIDI massager like this, you don't need that. You can say, okay, I see you. You're on 82. So let's go back to code. Let's say if the MIDI CC value is coming in on 82, number 82, I'm going to change you to be, how about 23? Okay, now if we look at my little display, it's still saying 82 because that's in reality what is coming in on that host USB cable there. But if I look in my VCV Rack synth software, I can say, all right, whatever comes into here, that is now 23. So you can use it for this sort of translation, which is pretty great. You could use it to clamp values, invert stuff, change the range of your pitch bend. Lot of potentially cool things that you can do with a little MIDI massaging device there. And there's other info we could ask for. We could say what MIDI channel is coming in. Again, this is probably sending on channel 1 right now. And you can change it on here. Sometimes the interface is pretty good for that. But I think it's not that great on this one. So again, I could come over here and say, if anything comes in on channel 1, let's send it out on MIDI channel 3, 4, and 5, because I have a variety of devices that are looking for that. So really exciting. The fact that we've got plug and play USB-A, type A on here. It powers the keyboard. This is getting power. You can see some lights on there. And gets the data onto here and then sends it back out over that USB-A cable to whatever device you're plugged into on the other end. And potentially we can use a real, this kind of USB DIN 5 cable, old school, one of those right there, and go out to more traditional MIDI gear, all off of that one feather with just a little added circuitry on it for MIDI. We got the MIDI feather wing we can use. In fact, I'll probably build this up as a little feather quadrupler, because then we can have the host, a screen, MIDI out, and then some USB or maybe a visualizer with NeoPixels or something like that. So all hugely cool possibilities here. This one, like I said, uses the Feather RP2040 USB host, which has PIOs that are being the USB host. We also have the Max 3421E based chips, and we have a Breakout, we have a BFF, and we have Featherwing. I think we got 2 or 3 things with that. So I'm going to play around with that and see what the state of that is. These are fairly recent library editions that Scott was working on, so it's fun to get in there and test them out. Right, I think that's going to do it. Tyeth has a question. If you got a USB power meter cable, curious what the combined system uses. That's a good question. I don't think I have one readily accessible right now. I should get one in here. Yeah, be curious, because we can draw, what, 500 milliamps on USB, and so this is providing something to the keyboard. I think these keyboards are really low. It's not doing much. It's lit up a couple LEDs, pretty low power chip in there, so I think these don't draw much. If anyone knows, Todd Kurt usually has a bunch of these USB current meters plugged into things, so he may know. So if you're in the chat, let us know, Todd. Okay, let me know if anyone has other questions. David Glaudet says you can use the boot button here as a MIDI panic. That would be a great idea. So as you may know, the boot button on the RP2040 can be used after you've gotten past the boot sequence, so you're clearly not using it to try to get into the bootloader. You can then use it as a user button, so that would be a great use for that. I love that suggestion. Thank you, David. I will set that so that it can be my MIDI panic to get out of trouble, which again is just a for 0 through 127 send MIDI note off I. Brr, runs through and turns off every MIDI note. Let's see, let me actually bring back the Discord here, see what other thoughts, questions, cool GIFs. DJ73, this was unfortunately common in many of the VSTs I've used. It happens often, and unfortunately can't really mess with a recording session. You're probably talking about stuck notes, yeah? Yeah, a big MIDI panic note button is important. Yes, thanks, Mike. Let me know when I wasn't showing that. Taba says, I always wanted to get one of those 49-way joysticks from Sinistar. Let's see what this is. They really had a 49-way joystick? That's wild. This apparently is a... Why? Why is there a 49-way joystick? That's some resolution. Wild. Okay. I think that's going to do it. Don't forget, if you want to go buy some stuff, MIDI host, that's your Coupon code of the day, so head to Adafruit, buy some stuff, throw it in your cart. On the way out, just type in MIDI host into that coupon code slot. If it's a thing that we can ship to you, you'll get the discount. If it's imaginary, conceptual, like a gift certificate or a subscription or software, no dice, no discount on those. We've got, I believe, Scott doing a deep dive tomorrow. There may be a Foamy Guy deep dive on the weekend, so check the Discord to find out more. And then we'll be back on Tuesday with Product Pick of the Week, Wednesday with 3D Hangouts, Show and Tell, and Ask an Engineer. And I forgot to say there'll probably be a Desk of Lady Ada sometime at various hacker times, possibly, but no promises. So that is it for me. I'm going to go play around with this, and this will be, I'll work this into a neat little enclosure maybe with that footprint that I talked about, and write up a guide on making your own little MIDI massager translator thing. All right. That is going to do it for today. Thank you, everyone, for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.